I wanted to start this discussion of using the bandwidth command to tweak our EIGRP route metrics here at show interface serial 0. We're going to be using the bandwidth command on serial 1, but the values there are going to be the same because I've left everything at the defaults. These values, MTU, bandwidth, delay, reliability, and then load, they are sometimes used in EIGRP route metric calculations, sometimes not. And in the next two videos, I'm going to clear that up for you as to exactly which ones are used, aren't used, or could be used. And I'll start here by saying that bandwidth and delay are the only two that are used by default by EIGRP route calculations. And in this particular instance, the lab we're going to run is going to be very similar or very familiar. We've got the 172.23.23.0 network. That's our Ethernet segment between routers 2 and 3. And with equal cost load balancing in effect by default in EIGRP, right now router 1's routing table is going to show 3 entries for that. At least I hope it does after I said that. And there they are. And you can see 3 routes to the Ethernet segment. Here's one via router 3's serial 0 interface, that's through the frame. Another one, the next hop, is router 2 serial 0 interface, that's through the frame. And then we have that direct link between routers 1 and 3. And since the value is exactly the same here, and what's that called? That's our feasible distance. It's our EIGRP route metric, but it's also our feasible distance. And let's run the topology table here and just verify that indeed you can have 3 successors, and there they are, and they're all in the routing table. But let's say that that link between 1 and 3 that doesn't go through the frame is actually a 56K link. Well, right now what we've got going on is suboptimal routing. Now, suboptimal routing is not as bad as a routing loop, certainly. I hate to explain what suboptimal routing is without sounding like a smart aleck, but it's routing that isn't optimal. And what that means is right now what we're doing is we're kind of splitting the workload 3 ways here pretty evenly, 1/3 of the load each way, but one of the links is actually much slower than the other. So we need a way to tell EIGRP what's going on there. And what we're going to do then is change that bandwidth value. Now I want to remind you of something here, and you're already saying he's going to say that thing about using iOS help. And you're right, I am going to say that thing about using iOS help. But here's why. I see a common error made here with the bandwidth command, and I think it's because the clock rate command is so familiar to us from lab work and from our studies, and you've got to put that on the DCE end, and it has to supply the clock rate. Well, it really doesn't matter if you put clock rate 56,000 or 64,000 on here in a lab environment. You're going to bring that link up. But I think we get so used to typing 56,000 or 64,000 here that when people go to the bandwidth command, they go bandwidth 56,000. And you definitely don't want to do that. Let's take a look as to why. And here's why right here. This is in kilobits. So you do not want to put band 56,000 if this is going to be a 56K link. Because what you're going to do is you'll actually be telling EIGRP that what we know is the slowest link is actually going to be the fastest link, because you're going to say, hey, those other guys are running at 1544 kilobits per second. I'm running at 56,000 kilobits per second. Actually, let's have a little fun. Let's do that. And I'm using it incorrectly, and you'll see why it has to be. It's so important. I just want to make sure that was serial 1, and it was. That it's so important that we get this one right. And we'll go back up to router 1 and take a look at the routing table. Any second now, there we go. And you can see now that it's only using one path to get to 172.23.23.0, and that is actually what we know is the slowest route. It's the direct link between routers 1 and 3. If we run show IP EIGRP top, we'll see why, because its metric would be so much lower, 793.600, and it would be much lower than that of the pass through the frame. So this is why we got to be so careful about the bandwidth command, and why, if you use iOS help for just a second, it's a really good idea. So what we will do instead is go back to serial 1 and enter 56 for the bandwidth, not 56,000. And I'll do it on the other end of the link as well. It's amazing what a difference 3 little zeros can make. Just amazing. So let's go ahead and Wait for that to cook, so to speak. And already you can see that EIGRP has already recalculated with those new bandwidth values of 56, and it's saying, okay, now we only have 2 successors. So with the other route then, do you think that would still be a feasible successor? You've gotten some numeric hints here. Let's take a look. Actually, it would be, because now you can see this is much more realistic, because we said at the very beginning that the links through the frame were T1 lines. We're going to leave those, but the line between 1 and 3 directly was only a 56K line. So you can see that its feasible distance is much bigger now than the ones going through the frame, but the reported distance is still the same. So since the reported distance is less than the feasible distance, that'll update in a second. 281,600 is much less than 219,5456, then we know it's still a feasible successor. So let's go ahead and test that out, and what we'll do in a lab environment, of course, is shut down serial 0. So of course, naturally, we're going to lose some adjacencies. So now we should see, if dual's doing its job and the feasible successor theory is all correct, we should see that route back in the table. And we do. There it is, 172.23.23.0, and now it is using that path. It's also using that path to get to its own frame network, because of course its own serial 0 is shut down. So we have the route back in our table, and it's the one going through dot 3. Now what I'll do is go ahead and open that interface back up. And I will pause the video here for a moment, because that'll take a minute or two to come up as far as our adjacencies over the serial link, and as soon as it does, I'll restart the video and we'll check out the routing table again. It's the old elevator button theory. I thought, well, that's been long enough. I saw the adjacencies come up. I gave it a few seconds. Ran show IP route EIGRP, and the one single route was still in there, but literally like 5 seconds later, you can see these routes have been in there for 5 seconds, that we're now using those 2 routes through the frame to get where we're going. So that's how the bandwidth command works. We also know how the bandwidth command shouldn't work or shouldn't be applied. And a couple of notes here about the bandwidth command too that I want to share with you. Let me move that down just a bit here. There we go. Here's something I wanted to share with you as far as the bandwidth command goes. Now you have to be careful with this, because the bandwidth value there is not EIGRP specific. That is, that's not the only protocol or service on the router that's using the bandwidth value. Other important routing functions use it too, particularly quality of service, which is a good way for us to set things up so that we're identifying the most important traffic and that gets priority, etc. It gets a little more complicated than that, but at the crux, that's what we're doing. And the bandwidth value that we just changed is intertwined in a lot of important QoS functions. So I'm not saying never use it, but I am saying watch your other processes, watch your QoS after you change that bandwidth value, and if anything does pop up, it is likely due to that bandwidth change. I will also say that this beats the living heck out of trying to change the delay value to get what you want. We're going to talk on the beginning of the next video about EIGRP metric calculation, exactly which one of those 5 values we discussed are used by default. We know that's bandwidth and delay, but we need to know whether the other ones can be used or whether they are used. We'll cover that, and we'll talk a little bit about the delay value on the next video. See you there.